Okay guys, so going back to the stat disk, we don't have to change what screen we are. I'm going to start with that scatter plot, but from there we're going to hit analysis and then choose correlation and regression, and then enter 1 and 2 as the columns of data we want and press evaluate. Okay, so again, I'm right here where I was with the scatter plot. Up here at the top, I'm hitting analysis. Then I'm given lots of options. I'm going to choose correlation and regression right here, okay? We've done confidence intervals and hypothesis testing so far, and now we're doing correlation and regression. And so it asks, select the columns to be used for X and Y variables. X, we're gonna choose 1, Y, we're gonna choose 2, because 1 is the sugar, 2 is the calories. Now, the only other thing we haven't talked about up here is the significance level. Unless I tell you to change the significance to something other than 0.05, just leave it as that. Okay, and then we click evaluate, and it gives us all this output. And I know I can already hear some of you thinking, oh my gosh, that's a lot to deal with. And it does have a lot of information here, so we need to learn how to pick out what we want. So let's read from the top. It says sample size is n equals 12. Well, yeah, there were 12 movie candies. And then the degrees of freedom is 10. Well, we haven't talked about degrees of freedom here. This does not have the same formula for calculating degrees of freedom as we used before because we have matched data. So just ignore degrees of freedom. We don't need it for anything. Next, we have the correlation results, and that's all we're dealing with right now. So these correlation results right here are all we're dealing with. The rest down here, ignore for now, okay? So just the correlation results is all we want. And it says correlation coef, standing for coefficient, R. That's what we want right there, that R value, 0.61820, okay? Your book talks a little bit more about the critical value method and the p-value method for determining whether this actually has a linear relationship and we should use that R. So I'm just going to mention this really briefly. If the p-value down here is less than your significance level, so is 0.03215 less than 0.05? Yes. Then there truly is a linear relationship. So we can use that correlation coefficient R. In general, we will have relationships that the p-value is less than 0.05 for the purposes of talking about R. But if you wanted to test to see if there actually was a linear relationship and you weren't sure, check that p-value. If the p-value is greater than 0.05, there is not a true linear relationship. And that's the example that's given in the book. I think they get a p-value of like 0.29, which is definitely greater than 0.05. And you can tell from the scatter plot that the relationship really doesn't look that linear. Okay, but for our purposes, we want to write down that R value there, 0.61820. Okay, so that's what we're going to write down here. And I'm going to round to 3 decimal places. I think having 5 there is a little bit excessive, so that would be rounded to 0.618. All right, so it also says to interpret the correlation coefficient. Now, this is where we use these 3 pieces from the description of an association. Again, it doesn't tell us unusual features, right? It doesn't say anything about whether there are outliers, so we just talk about the strength, direction, and form. Okay, so first of all, 0.618 is between 0.5 and 1, so it's moderately strong, like we said before, closer to 0.5. It also is positive, right? We don't have a negative relationship here, so we're going to say moderately strong, positive, and then linear, because we did check the scatter plot and it is linear. Okay, so we will say there is a moderately strong, positive, linear relationship between, let's see, what were our variables again? Between sugar and grams and calories in movie candy. You should always include that context, so always explain what the 2 variables are that you're talking about. Now, notice that sentence is very similar to the sentence that we were able to use to describe the association based on the scatter plot. But again, this is based on the scatter plot, and this interpretation is based on R. Okay, again, the only thing we couldn't bring up was the unusual feature. Now, notice I also put that scatter plot from StatDisk on this page, and I pointed out that that is the peanut M&M value. So number 2 says, what effect do peanut M&Ms have on the correlation? So we kind of talked about this during the big ideas, that correlation is non-resistant. So if the outlier is in the pattern, it strengthens the correlation. The outlier is out of the pattern, it weakens. So I think we can tell that this dot here is outside of that pattern, that linear pattern we're looking at. So it weakens our correlation. So let's write that. Peanut M&Ms weaken the correlation since they are outside of the linear pattern. Okay, I could ask a similar question, let's say, about this value here. Now this outlier would strengthen the correlation because it's in the linear pattern. Okay, so then the last question, number 3, says, most people love chocolate for its great taste, but does it also make you smarter? I wish. A scatter plot like this one recently appeared in the New England Journal of Medicine. The explanatory variable is chocolate consumption per person for a sample of countries. Okay, so that's important. The explanatory variable is the chocolate consumption per person for a sample of countries. We can see that down here. The response variable is the number of Nobel Prizes per 10 million residents of the country. We can see that over here. So it appears there's kind of a linear pattern here, right? It says R is 0.791. So that would tell us an even stronger relationship than the relationship up here, right? 0.791 is closer to 1 than our 0.618 was. And again, it's positive, so I can tell this is a positive relationship. I can see some outliers here, right? Switzerland looks much higher in both values than anything else. So I think Switzerland would strengthen the relationship because it's in pattern, but it's still an outlier. Whereas Sweden looks like an outlier that it's out of the pattern, so it would weaken it a little bit, okay? So the question though is, if people in the United States started eating more chocolate, can we expect more Nobel Prizes to be awarded to residents of the United States? So I see that I have a relationship between chocolate consumption. The higher the chocolate consumption, the more Nobel Prizes in general. But can I assume that chocolate consumption causes the Nobel Prizes to go up? Just increasing chocolate consumption, can I make the Nobel Prize increase? No, okay? Correlation does not equal causation. There is most likely something else causing both of these things, okay? So no, correlation does not mean that one variable causes change in the other. Okay, there's no indication of causation here. There is probably something else impacting both variables. Right, there's probably something else behind both of these variables, like maybe the economy in the countries. Right, so it's probably, or it's more likely that a high economy leads to higher chocolate consumption and more Nobel Prizes. Or it could be smaller populations with higher economy, things like that, right? Really, we don't know what causes, right? Or what causes both of these, but we have an idea that this variable does not cause this variable. And I like this idea because we can also think about the sugar and calories situation. We can tell that as sugar increases, calories is also increasing. But is that because sugar is increasing? Well, we can tell that some of these variables are not just impacted by sugar. So let's think about the peanut M&Ms again. They have a kind of medium sugar level compared to the other values, right? But they don't have a medium calorie level. They have a high calorie level. So is there something else that's causing the calories to go up? Well, I think it's in the name, peanut M&Ms, right? Peanuts are really high in calories, but they are not a sugar. So there's something else within the peanut M&Ms that is causing that higher calorie count. Okay, so again, there's a relationship between sugar and calories, but we cannot say that sugar is the sole cause of a change in calories. Okay, in the next video, we will move on to talk about how to find that best fit line that I keep kind of sketching in with my pencil and my finger here.